Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving modulus function, right? So here we have to find the value of this definite integral which is from minus pi by 4 to pi by 4, and here we have the integrand as mod of sine x, right? So let us start. So let us first call this integral as I, right? Now here, in order to evaluate this definite integral, we'll make use of some properties of trigonometric functions, right? So here the integrand is, say, f of x, that is mod of sine x, right? Now here we'll make use of the sign convention of trigonometric functions in the four quadrants, right? Now see, here we have the four quadrants. This is the first one, this is second one, this is third, and this is fourth, right? So now we know that the sine function is positive in the first two quadrants, right? So sine function is positive in the first quadrant and in the second quadrant, and sine function is negative in the third and fourth quadrant, right? And see, here we have to integrate from minus pi by 4 to pi by 4, right? So see, we know that when we measure an angle in trigonometry in anti-clockwise direction, then the angle is positive, right? And when we take the angle in the clockwise direction, then it is negative, right? So this angle minus pi by 4, it lies in the fourth quadrant, right? So this is an important step here. So this angle may be taken as minus pi by 4, right? And here we have the angle 0, right? So the lower limit is minus pi by 4, which lies in the fourth quadrant, right? Okay, now the upper limit is pi by 4, and pi by 4 lies in the first quadrant, right? So this is pi by 4, and this angle is taken as positive, right? So we have to integrate from minus pi by 4 to pi by 4. So it means we have to travel from fourth quadrant to the first quadrant, right? And in the fourth quadrant the sine function is negative, and in the first quadrant the sine function is positive, right? So now by definition of mod function, see, the mod function is defined like this: mod of p is positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is negative p when p is less than 0, right? So here we have mod of sine x, right? So mod of sine x is negative sine x, right? So mod of sine x is negative sine x when this x belongs to the fourth quadrant, right? So here we will use this notation, right? And mod of x, mod of sine x is positive when we are in the first quadrant, right? So when we go from this angle, that is 3 pi by 2 to 0, then this mod of sine x is negative, and when we go from 0 to pi by 2, then mod of sine x is positive sine x. So now we can break this integral as a sum of two integrals, that is I1 and I2, right? So I1 is from minus pi by 4 to 0, right? From minus pi by 4 to 0. And when we go from minus pi by 4 to 0, it means we are in the fourth quadrant. And in the fourth quadrant, mod of sine x is the negative sine x. So mod of sine x should be replaced by minus sine x, right? and then we go from 0 to pi by 4, right? 0 to pi by 4. And when we go from 0 to pi by 4, then we are in the first quadrant, and in the first quadrant sine x is positive, right? So mod of sine x is positive sine x. So now we have these two integrals to evaluate. So now let us use the formula, that is integral of sine theta is equal to negative of cos theta, right? So here we have the negative sign, and the integral of sine x is negative cos x, and the limits of integration are from minus pi by 4 to 0, right? And here the integral of sine x is negative cos x, and the limits of integration are from 0 to pi by 4, right? So now this negative and this negative, when multiplied, it becomes positive. So we have simply cos x, and the limits are from minus pi by 4 to 0. And here we can take this negative sign outside, so we have minus, and here we have cos x, and 0 to pi by 4, right? So now we have to simply substitute the limits, and we'll take the difference, right? So here first we'll take 0 here. So we have cos of 0 minus cos of minus pi by 4, right? And here we have first pi by 4, that is cos pi by 4, and then we have cos of 0, right? And see, here we have cos of minus pi by 4. So we know that cos of minus theta is simply cos of theta, right? So we can now write cos of 0 is 1, and here we have simply cos of pi by 4, and here cos of pi by 4 is 1 over root 2, and cos 0 is 1, right? So we have 1 minus cos pi by 4 is 1 over root 2, and here we have minus 1 over root 2 plus 1, right? So this minus and minus becomes plus. So we have 1 and 1, 2, and minus 1 over root 2 and minus 1 over root 2 is minus 2 over root 2, right? And now we can rationalize this denominator. So we have 2 minus 2 over root 2, and here we have root 2 over root 2, right? So this is 2 minus 2 root 2 over root 2 times root 2 is 2. So 2 and 2 get cancelled. So we are left with 2 minus square root of 2, right? So the value of this integral is equal to 2 minus square root of 2, right? So viewers, this is how, by making use of some simple concepts from trigonometry, we can evaluate these type of definite integrals.